So I want to talk about academic publishing and about research. And the short story and also the reason, and we're going to dig a little bit deeper into the technology behind what we do. This is not going to be just a marketing spiel talking about what I just was chatting about in the back here. But we are not just doing research, we're also building tools for researchers, which is why this stage and this crowd is a good fit for us. And the short story, and we actually had a piece coming out in Times Higher Education this very morning about it. The average cost of a UK library, which did this big Freedom of Information Act request, the average cost of a British university is about £4 million a year in cost for academic research. The costs have tripled for the past couple of decades. Just the last 7 years or so, it's increased with 60%, adjusted for inflation. So essentially, I'm going to propose today that science is in trouble. And we've kind of identified in our work 5 major reasons why this is. Well, first of all, there's an information overload. And obviously, we're going to talk about AI and how it relates to information overload. But there's also a lot of built-in bias, which is also important to keep in mind. And we're going to have talks later today about biases in data sets. And I know that there's the ethics and AI stage, where we're also going to see a lot of talk about that. Then there's reproducibility issues in science. There is access issues and these major barriers, especially around paywalls. And finally, this all creates this radical incentive structure misalignment, right? For those of you who are academics, you know this. You have to publish in a Tier 1 journal to get the right points, to get your next round of funding, to keep your job. And it's this eternal cycle that forces academics more and more. I mean, you want to get into the Tier 1 journal, so it's not that you deliberately are going to polish your results, but you want them to sound really nice, right? And if you've been working for months or years on an experiment and it turns out it fails, like, what have you been doing, right? And so we started this company 3 years ago to tackle parts of this, and we realized that tackling all of this, all of the problems of academic research is going to be a massive overload, but we started simple. We started with the information overload, and there was an animation highlighting the information overload piece, but it'll come next, I guess. Sorry about that. So this is my founding team. We started this company 3 years ago, and we started, there we go, with the information overload and the built-in biases of academic published research. And so what we're doing, we've built a set of tools, one specifically that I'll introduce today, that we work with the researcher in their research projects, doing what some of you might know as systematic research landscape mappings, or literature review, if you want to call it that. So basically going from, defining a problem. What is it that you're solving? Whether it's the thesis of your, or your research question of your PhD thesis, or, if you're in industry, it's that, problem statement where we need to build a reusable rocket out of, composite materials. The challenges with, bringing a rocket to space is that, and you formulate in your own words what problem you want to solve. Then you explore broadly. You go out and do a massive literature search, which today is managed by massive keyword queries, which is problematic because if you do a keyword query, you need to know what you're looking for. And in a lot of these instances, you are dealing with unknown unknowns, especially so in interdisciplinary research. So you don't know what you don't know. How can you make a keyword query around it? In any case, you explore broadly. Once you have a data set of, say, 10,000, 20,000 articles, then you need to focus that down to a precise reading list. And that is exactly what we do and what we have semi-automated. I'll give you a couple of quick intros to the tools. This is the exploration tool. It looks a little bit different than your average research tool. We're getting kind of a love-hate reaction from researchers on it. It's either like, oh my God, this is amazing. It's a brand new way to kind of get all the results of each of these maps. So this is basically you input a research text, a description of your problem. We build out this map, and I'll get into the tech in a minute. But we build out this map, and we give you a visual overview. You can navigate into each of the sections, and you'll find research papers on the different topics in each of these sections. So what we do in this tool, to get a little bit more technical about it, we combine key information extraction. So we extract the most meaning-bearing words from the text. Then we work with contextual synonyms to find essentially what other words people have used for the same topic in different research papers. We've trained that on a data set of about 18 million research papers. And then we use topic modeling to find what topics or what hypernyms are also applicable to this text. What context are we talking about here? And we also work with marking, contextually disambiguating information, etc. The context analysis, what we do there is we find contextual synonyms. As I said, we feed them. We use a word-to-vec model to find contextual synonyms. So feed the machine the 11 first words of the first sentence of the first paper, ask it to guess the word in the middle, do that repeatedly across 18 million articles, and you're going to build up a vector space of how similar are these words to each other or not. We take those words together with topic modeling, where we build one vector space of clusters of documents, and then we ask the machine, what is the probability of using these words to describe this cluster? And so we use those three groups of words to together form what we call a fingerprint of the document. And that fingerprint is a weighted matrix. We go out and do fingerprint matching of other documents. That algorithm is developed by us. It's called Wisdom, and there is an open access research paper out on it. So this is what we do to take one text, make a fingerprint, go out and do fingerprint matching. And then we pull all of that in this visual format that you saw. And so what we've seen, and we've managed to prove this, and there's another research paper out on the effect of this tool, because we're like, okay, you combine neat UX with some cool backend tech, and what does that really give you? So we've had these experiments running where we have multiple teams competing to solve the same research challenge over a set few hours, and what we've been able to prove is that consistently teams that use our tool, they consistently outperform teams that use, say, Scholar or PubMed and your average search engine. And that goes whether or not the person is kind of more of a junior level, master PhD student, or a more seasoned researcher. The results are consistent. So that's great. In this process, you're going to end up with like 10,000 papers, maybe 3,000 papers. Takes you a little bit closer to where you need to go, but not all the way, right? Which is why we built the focus tool, where you can import a corpus of documents, and we use similar kinds of tech, but this time on the entire corpus, and we analyze it to find what are the key terms, so you can tell the tool in an iterative fashion, I know that in this 10,000 documents, I was looking for, say, you're looking for autonomous vehicles and a specific problem formulation there, but you saw that there were papers there on underwater drones, which is, can sometimes be overlapping, right? And you're like, no, in this specific instance, I don't need to look for drones, and you tell the machine that, and you iterate down based on the vocabulary of the documents, and again, on the topic model. So you can iterate down to a precise reading list with this. And what we've found is that in the course of 2 days, you can do the exploration and the narrowing down in an industrial setting. Now, if you work in the academic space, you need to do a lot more manual verification to make sure you covered everything. But this is what we're doing today. And we're doing quite well in this. Fast Company announced us to be one of the top 10 most innovative companies, AI companies last year. We've raised a couple of $1 million in impact investment funding. We have paying clients, and this is for our clients, is about $138 billion yearly budget, which is exciting. We have a lot of registered users. Proven technology, as I said, we've published open access papers on it. So why am I here and it's still halfway through the talk, right? Because what we're doing is exciting, but for us, it's not enough. Because there are so many issues in the realm of science. Like right now, our tools work off the bat. The first half of the tool is entirely free, so you can go use it, and it works with open access research off the bat. We can combine it for organizations that are paying for premium access for paid journals. We can merge that with their own credentials. But that doesn't help that single academic researcher or the startup kid who wanted to build this deep tech company or whatever it is, right? Science today is locked behind these paywalls, and it's not getting accessed. And so we found ourselves in this situation where we could kind of scale up our B2B sales to the big energy manufacturers and engine manufacturers that we're already selling to. We could just do that and go home and get rich. But that's not really why we're on this planet. So we decided that we were in a unique position to tackle this, which is where this session now is going to deviate off of AI and into blockchain for a little bit. And we decided, with our kind of growing frustration that selling B2B software isn't going to change the world, surprise, with that growing frustration, there was also a massive growth of the blockchain industry. We've been paying attention to it since 2015, but like obviously in 2015 there wasn't that much you can do beyond Bitcoin and a few kind of pet projects. But as kind of the blockchain project ICO boom happened last summer, we saw an opportunity. The reason why we've decided to go into the blockchain space is that what we're dealing with when it comes to scientific research is really what we call a two-sided marketplace without set prices. Like, how much is a research paper worth? How does Elsevier decide how much a research paper is worth? How, like they set their prices, right? Which I just said in the beginning is about 4 million British pounds per year per academic institution, which is really just our tax money that they're charging us, again, for research we've already paid for that arguably belongs in the commons. But so we're dealing with a two-sided marketplace without set prices. Blockchain allows us to build new economic models from scratch and remove some really powerful middlemen, and it starts sounding like that might be an interesting use case for these like big publishing houses that are holding on with deadly force to their content. Blockchain allows you to do communal property. Again, I believe that science should be open, free, and validated and available to everyone. Communal property sounding interesting. And there's some aspects of pseudonymity that is also really intriguing that I won't go into that, beyond mentioning that there are people, there are researchers and academics in the world, maybe especially so in political science and archaeology and anthropology, that aren't able to publish freely what they're thinking in their country. So this is kind of what we're thinking right now, or what we started thinking about last summer. And that is why I'm happy to introduce Project Aiur today as well, which is, I once called it a side project. It now takes absolutely all of our time. And what we're working on is a community-owned project. So Iris.ai, the commercial entity, we're launching this, and then it's essentially a not-for-profit for us. There are reasons why we're doing it, and I'll get back to that later. But it's an entirely community-owned project where we can build a new incentive model for academic publishing from scratch. So imagine a world where you would get paid to peer review. You would get paid to, later on, challenge someone in a research paper that you 10 years later find to not be valid anymore, et cetera. So any contribution you make to the world of science should be rewarded to you. And that is the incentive structure that we're building. However, there's quite a few blockchain for science projects today, and there's a little bit of a chicken and egg problem. I do not believe that you can just build publishing on the blockchain and people will come running to publish, because there's enough open access journals that have tried this, it doesn't work. So what we're doing, because one of the issues as well, of course, with open access and like just opening up science to the world is like, how do you validate it, right? The publishing houses today claim that they're the barriers and the gatekeepers to quality research. I honestly call bullshit on that, but that is their claim, right? But we still need systems in place to make sure that the research that is out there is quality. So what we're going to do is that together with this community, and again, community-owned, community-governed, we're going to build what we call a knowledge validation engine. And I'll go into a little bit more in detail in a second. And by building an open way of publishing that gives people the right incentives, combining that with an engine to actually validate a piece of knowledge, and it's not a binary yes or no validation, just to be clear on that, we can actually build a validated and sort of live collection of research that is being updated with validation scores that can be challenged at any point. So we actually have a living, vibrant piece of knowledge or collection of knowledge, as opposed to today where you put your paper in, you get it stamped with a peer review that may or may not be, is an entirely intransparent process, and then it's put in a vault somewhere and never to be seen again. So that is what we're fixing. The incentive model, very briefly, people can earn tokens. Users can earn tokens through AI training, through coding, through quality assurance, and eventually also publishing failed results, and peer reviewing. And with peer reviewing, it's both the I am now publishing, we're going to peer review, but also the longer term kind of going back to older research and peer reviewing again based on new information. So these are ways that users can earn tokens. Now you can also spend tokens. First of all, we are opening up the premium tools that we have as a commercial entity. We're opening them up so you can actually pay with these Aiur tokens that we're going to be issuing. You can pay to those premium tools. As the knowledge validation engine is being built, you can pay for access to that one as well. And anyone can build third-party services on top of the Aiur platform, again, that is community-owned and community-operated. So let's say that someone wanted to build a patent claim validating tools or a tool for venture capitalists to easier assess the technology behind a venture they're looking at. Or maybe someone wants to build a tool for tracking corporate money into R&D spending and seeing how are the quality of the papers coming out of that and track that together with the streams of money. If someone can please build that tool at some point, that would be great. So any kind of third-party tools like that can also charge in Aiur tokens and also will then pay to get access to the core engine. So we're building kind of a nanoscale economy around research. And as larger companies and corporates come in and want access to the technology, they have to buy tokens, spend them, and the value of these tokens and the value of the community will increase. And again, this is entirely community operated. So this will go back to the academics and the researchers. The knowledge validation engine that we want to build with this community is, we're calling it semi-automated peer review. If we want to do that, that's a simple summary of it. Basically, you input a paper, a hypothesis, or a report into this engine, and what you get out, what the engine does is, and this is a 4-year undertaking, just to be clear on that, we extract the hypothesis of the paper. We do argument mining to find each single building block. We match those building blocks up with the building blocks found in other papers and build out a truth tree of the paper. And then together with that truth tree, we can backtrack all the assumptions and flag, for example, you talk about a specific protein and you want to use that in a medical application. There's another paper that talks about that protein only functioning on a certain, temperature range. Well, we might flag that for you and say this might be a constraining factor for you. And all in all, you can give the paper a reproducibility score or a validity score. And of course, there's several detailed steps in this roadmap, and you can check that out on our website. There's a white paper with a pretty substantial technology roadmap for those who want to check that out. The validated repository that I mentioned, the interesting part is that we don't really need people to start publishing papers with us right away, right? The core engine is going to be there and going to be built and going to have value. As the content grows, you can choose to publish through our tool into open access repositories, or you can choose to simply keep the paper to yourself and publish it paywalled, but then you actually have to pay for access to the engine. But we can also do failed results publishing, which is exciting. And this will always be a parallel track. We would never require anyone to publish only through the system. Again, it's all about openness and accessibility. I'm running very short on time, but I'm going to just wrap it up with this. We initiate this project. We are not the owner of it. There's a 2% ownership cap, meaning we can also only own 2% of the tokens. Anyone can own 2% of the tokens, but this also means that the big publishing houses cannot come in and buy this up. There is a limitation to how much of the project you can own, and that does include ourselves as well. So we're kind of painting ourselves out of the picture while we're still the good guys, so we don't end up being the bad guys 10 years from now. That's our basic hypothesis. And I'll just skip this part. Briefly, why we're doing it, and then I will wrap this session up. We need this knowledge validation engine to be built. And I know there are other companies working on it too. But here's the basic principle. I do not believe a knowledge validation engine should be owned by a commercial company. Like if you have an engine that finds the, and I'm going to use big quotation mark, truth of research, you cannot have that owned by a commercial entity. It has to be communally owned. And that's why we're doing this. There is some strategic revenues for us, some first mover advantage and kind of a Linux Red Hat model. But finally, we are in this to change the world of science, to make it open, to make research papers open, accessible, and validated. And that's why we're doing it at the end. I'm going to just skip through the last couple of slides. We do have a private sale going on right now. If anyone wants more information and are in the kind of crypto blockchain space, you can come talk to me about that afterwards. And here is my contact information if you want more details. So thank you very much for listening.